Okay, so I'm just going to do this in Excel now for you. And like I said, a lot of this is already done. You know, Excel does everything now. And that's kind of where I want you to go. But again, like more importantly, it's about interpreting what you're doing and knowing why you're doing it. So this is a simple scenario about this coin of ours. And I'm gonna throw it more times, but you know, I'm just going to for now just show you, just to stick with the question that we've been working with. If I throw up my coin, so I've got my symbols here, n, and n is equal to 3. Remember, we throw up our coin 3 times, and the probability of success, if you like, was 0.5. We have a fair coin. This can change, and I'll change it throughout just to sort of show you where we're going. So if the probability of success is 0.5, that means the probability of failure is also 0.5, and we could call that Q and give it sort of some sort of figure, letter P and Q. And so X, of course, is the number of times we actually throw the coin up. So, you know, for example, the probability of what it is I'm looking for. So either 0 success or 1 or 2 or 3. So if I can literally find out, I can work out what the probability of success is for each of these scenarios. So I can say the probability of no heads, 1 head, 2 heads, or 3 heads. So like I said, Excel is very good. What you pretty much simply do is sort of write out your material that way. And then what you do, you go to formula and you type in, oh, it's already there. Just put in binom. Once you start typing B-I-N-O-M, it'll come up with it. And you just click go to it, or you click OK. Oops, sorry, 1 second. Do it. Oops, let's do that again. So I go there, and what do? I go here, and I go to more functions, and I go to binom. There it is, and I click OK. And it comes up with this. So it's first of all, it's asking, what is your n? Yes, what's my n? And it even gives you a definition. N here, or S, if you like, is the number of successes in the trial. So for example, this is going to be my n. For example, I'm just going to start with, oops, sorry. Yes, I'm going to start there. That's what my n is. Second. Sorry, why is it not working? Let's start again. More functions. Binomial. So the number of successes in my trial. So I'm going to have that. Good, and let's pick that up. Then you can see it says trials. The number of times you're going to flip this coin. The number of trials here is going to be 3. But remember that I want to fix this, so I'm going to do what we talked about with the dollar signs on both sides. And probability is the probability of success of each trial, and we agreed that was 0.5. I mean, that can change depending on what it is we're talking about. And cumulative, am I adding up my values? No. So I just write false. And then I click OK. And you can see it's 0.125. I've already sort of created a chart to sort of map everything out as we're going along, but we can discuss that later. It doesn't matter, you can always create a chart easily. And I could just drag down. Now, if you look here, you will see, right, that I'm just going to make this even. This is no different to what I did when I calculated my figures. Let me just go back. So you can see 0.125, 0.125, 0.375, 0.375. So if I come here, right? So if you look at this, scenario here, remember we said that we had. Let's just go back to when everything was 0.5 and nice and neat. You had 0.5 times 0.5 times 0, which was 0.125. for your heads when you have 3 heads, or you have no heads. So both are 0.125 as we can see from the chart. And then we had 3 of each, right, for the 2 heads and 3 of the 1 heads. So you times 0.125 is giving you the 3 times 0.125, giving you the 0.375, right? So that's, oops, this always keeps disappearing. I don't know what's going on. So you can see that the computer has pretty much done exactly what I've taken this time out to do via my charts, and then it kind of gives you a kind of a chart, so you can then sort of say, chances are there's an equal chance of getting either 1 head and 2 tails. Sorry, yeah, 1 head and 2 tails, or 2 heads and 1 tail. Quite the same sort of thing. Now, what's more important here is that I could ask the question, what's the chance of getting at least 2 heads? And that would be me adding up these 2 together, right? That's the important thing here. I'm really trying to get you to do. What's the chance of you getting at least 1 head? That's you adding up all these 3 together, right? Because probabilities add up together, right? And because you can imagine the probability of getting at least 1 head, it must be more than 1, right? It's the 1 head, it's or 2 heads, or 3 heads. So it's adding all of them together. Right, and then we could carry on. I could have extended this, so I'm just going to do that now. You can see it 1 second. It'll fix it in a second. 7, 8, 9, 10. So I could then say, okay, then, because all I'm doing is just changing scenarios. Look at that, right? I could then say, okay, I'm going to toss this coin 10 times. What's the probability of success of no heads? You can see it's very small. Probability of 1 head, probability of 2 heads, probability, again, you can see as I get to probability of 5 heads, it's probably the highest probability. And I could do exactly what I'm doing, what I'm saying over there, and I could carry on. You really could extend this if you wanted to, whatever, all the way, why not, let's have some fun, and just go all the way to 20. But the key point is that you can understand where I'm going. Oops, sorry, I'll stop at 15. Let me change that to 15. Oh no, I can't because my graph won't let me. No, my graph won't let me do it. Okay, no, I'll stop at 10. Okay, so we'll stop at 10. So that's that. So you can have 10 trials. Now here's the thing. Let me skew this a little. So if the probability of my success, or the probability of me getting, I could change my P. So if I say that then what could happen is, if I change that. Say, for example, this was an unfair coin, or I was dealing with a different scenario about rain or sun or whatever, and it wasn't 0.5. If I change that to 0. Say, for example, there's a strong probability of me getting that. You can see, right, that this is asking the probability of me getting no heads. If the probability is so high of success, well, of course this is going to be very small, right? Because I'm telling you that there's a strong probability of success. So the probability of me getting no heads is very small. 1 head, very small. 2 heads, very small. Because the probability of me getting a head is quite high. It's a heavy coin weighted towards a head. So these probabilities of getting no heads are very, very small. And you can see it increasing, telling me that, wow, it actually will shift towards me getting closer to, if you like, 8 heads, which tells you straight away. I mean, you can see this. Someone says you throw up a coin 10 times. What's the probability of you getting? How many heads are you likely to get if the probability of getting a head is 0.8? You automatically will say 8 times, and you can almost see it heading towards there, which means the mean, if you like, is 0.8 times 10, which is 8, if you like, right? And you can see the probability is highest at 8 heads. And I could have flicked this the other way. I really could, couldn't I? I could have done that. And you will see that it flicks entirely the other way. It's 2. It's weighted towards 2, isn't it? 0.2 times 10. The probability is highest at 2. And so, again, I could add parts and say, what's the probability of a defect? What's the probability of something not being, of not working? if you like, or probability of something working. And as long as I can assign some probability to it based on prior knowledge, then you can create a chart and you can create some probabilities. Cool, great stuff. So I will end the video there, and what I want you to do is to I'll discuss with you one-on-one, and I think it'd be amazing if you could come up with a scenario of your choice, any scenario of your choice, and almost build it up and create some probabilities using the binomial and again, talk about seeing how you can add things together, probability of things actually happening by adding things together to see whether, so you can say greater than or less than, probability of picking 50 things or 25 things, and what's the probability of having a certain number of defects where that's your P. So always the probability of success is the probability of you finding defects, for example. So the smaller it is, if you like, you can then work something out based on that. But this first lecture is about you going through the theory and being comfortable with it and settling it, and then you can come back again and think about how you could come up with some examples. I hope that's been helpful. Okay, great stuff. See you.